So it was all the odds for the homework because I want you to check the back of the book and come to class on Monday with basically everything correct. I'm not going to say, well, I didn't know. I didn't. You can look at the answer, work backwards, and you kind of know what should cancel, what doesn't cancel. More importantly, that's one of the hardest things on this chapter, on this section, is what not to cancel. We get really eager to want to make the answer small as possible, but we gotta look at things and say that even though we might have x plus 4 over x plus 2, this does not cancel. This is a number here, and so is this. They're not the same number, so they don't cancel. The way to test something if it cancels or not is you plug in a number and you see if indeed it works. So if I plug in any number, let's say x equals 2, and I plug it into both, I have 2 plus 4 over 2 plus 2 equals 6 over 4. Nothing really cancels. Okay? Nothing really cancels. As opposed to, well, we'll go through a few more of these. If I had something like this, if I plug in x equals 2, I'd get 2 times 2 plus 1 over 2 plus 1, which equal 2 times 3 all over 3, which would equal 2. Yeah. So the x plus 1's do cancel, and I'm left with x equals 2. So there's a way to actually check to make sure things actually cancel before you just assume, well, they look alike, so they must cancel. That's not necessarily true. Most common mistake I would say would be, yeah, something like this. People really like just to cancel this out. It does not cancel. This is the number 2, and this is 2 more than some number that we don't know. We don't know if these are canceled. How do we know if 2 cancels here unless we know what x is? If x is 5, that would be 7 over 2. 2 doesn't go into 7. Right? We can't tell just by, in this format, if 2 divides into this number on the top or not. So therefore we cannot cancel. So resist that urge if you have it, that, well, it's the same top and bottom and that always cancels. Now, when is that true? When is it the same on the top and bottom and you are allowed to cancel? It's when it's multiplication only. So remember all those, you probably heard this over and over and over. There's different rules for multiplying and adding. 2 negatives when you're adding, make a negative. 2 negatives when you're multiplying, make a positive. There are different rules. We cannot use all the rules for multiplying, like right here, when you're doing some adding and subtracting. That's the biggest difference. If you believe in that in every math problem, as you're learning things, you'll start putting things in different like areas. Like, okay, this is an adding rule. Here, I use it with these other rules. This is a multiplication rule. I use it with these other rules. You saw the same thing. I don't know. What's a good example? 2 plus root 2 squared. Is the answer 4 plus 2? Can you just simply go 2 squared and root 2 squared and get 4 plus 2? Say no. No, you can't. It doesn't work. It's added. When does this work? If it was 2 root 2, 2 times root 2 squared, yeah, then it's 4. That's 2 squared root 2 squared. It's 4 times 2, which equals 8. That's true. No adding, subtracting. We have adding, subtracting. You got different rules. We know the difference of what kind of problem we're working on. We know what we're allowed to do and what we're not allowed to do. Before I leave this page, the tests are pretty much almost graded. I mean, we have a lot of makeups from the field trip yesterday, probably a good 22 tests total in all the periods combined. But they'll all be on School by the end of the day. Maybe by the end of 6th period. We'll see how fast it goes. Okay, so your homework. Let's just go to the homework and look at that. Looked like this. So as you can see, like 17 and 31 and 25 and 33, not 33, no, just 17, 30, 25 and 31, you don't see any adding subtracting signs. So those are different rules. You can just cross cancel, cancel anything that you want, no problem. These are the easier problems. When there's no adding, subtracting, 23 as well. No adding, subtracting, super easy. Just cancel anything that's the same on the top and bottom, just like we've been doing. It's when we have these adding, subtracting, we have to do some factoring. Factoring basically takes an addition problem or subtraction problem and makes it multiplication. For instance, these are not the same. C plus 5 is some number, 2C plus 10 is some other number. Okay, the only way I can cancel out is if I have the same number on the top and bottom. So what you can do is say, alright, factor out 2 out of the bottom, and now you have a C plus 5. So now you have the same exact number being multiplied now. You notice how this factoring process takes it from addition problem to a multiplication problem. Remember, the multiplication is when you're allowed to cancel. As soon as it's multiplication, like on 17 or 23, if it's just being multiplied, everything cancels. And that's why we do this factoring business, is that we had 2C plus 10, addition problem, turned it into 2 times C plus 5. Now things cancel out. So factoring is just about converting basically to a multiplication problem. We can cancel out factors. We can't cancel out things being added and subtracted. Is there anything on here that just looks crazy? I wouldn't know how to start it. Anything like that? Yeah? 33. Okay, so the way to do these, it's this x plus y over 2x minus y divided by, this is division, divided by x plus y over 2x plus y. The way to do this is simple. On the bottom, multiply by the reciprocal and do that to the top and bottom. Why the reciprocal? Because it cancels everything out. If I multiply by its reciprocal, it equals 1 by definition. That's what reciprocals do. They cancel out and equal 1. But of course you have to do the same thing to the top and bottom. So on the top I'll have a 2x plus y over x plus y as well. And then you just need to cancel out what cancels out. But the bottom just becomes 1. Everything cancels out on the bottom. All you need to worry about now is this problem right here. What does that simplify to? Okay, same thing on 31. You just multiply by the reciprocal. Q over p squared. Notice how I put the negative on top here, just so I don't forget about it. That is a negative right there. It's very hard to see. Rarely will you see written like this with a division sign. This is elementary school division. We don't really use this symbol anymore. It's from a long time ago. You want to use division bar. So I can easily rewrite this as p cubed over 2q all over negative p over 4q. Okay. And then solve it like I would right down here in the bottom. Multiply by the reciprocal. So yeah, try to get away from using this. It's okay if you use it a little bit, but by the time we take the test, this symbol should not be there. It's just not used in any math class over or from algebra and above. In my opinion, it shouldn't even be in this book. It's just the elementary school way of writing division. What does division sign mean? Ever look at a division sign closely? Yeah, it's a fraction. This means a number over a number. That's what a division sign is. It's a fraction. So why do we have it? I don't know. Shouldn't have it in algebra or above. It's always written as a fraction. Okay. Anything else up there? Anything we don't know how to factor? What about right here, 29? How would you factor p squared minus 49? What does that equal? Quickly. It's a fast factor. What is it? Okay, it's p squared minus 7 squared, but how does it factor? The difference of squares, right? What does that factor to? Yeah. P plus 7, P minus 7. Yeah, P minus. Yeah. So we'll get good at recognizing anytime you see 49, 64, 25, 36 squares, and it's right after a subtraction sign, that's a good sign. It's just difference of squares. How would you factor the top here? What would this factor to on top? Yeah, exactly. You recognize there's a 3 in both of these. We're going to be doing a lot of practice with this coming up next week for the warm-up. We're going to have the clickers. We're going to have a lot of multiple choice. I expect you to be able to look at something like this and have that answer in 5 seconds or less. This isn't something we have to take time for, and we need to, really think about. Once you do enough of them, you'll see the pattern and it'll click. And I'll put like 5 or 6 of these in a row. So if you didn't get the first 3, you'll catch on the pattern really fast, and then from there on, you'll never stop and pause and wonder, how do I factor this? Or something like this, the GCF, you'll just start seeing, there's a 3 here, a 3 here. I'm sorry, that should be a 7. You're right. Same thing here, there's P in both of them, got to pull the P out. You got to be able to look at these and say, there's a 4 and 4, okay, take out that, W plus 1. Okay, cancel, cancel. And we've got to get really good and real fast at doing this. What about these trinomials? How do they factor? If you recall, there's many different methods, but here's one of them. You always multiply these two numbers together. So in this case, it's just 1 times negative 12, which is negative 12. And the number right here is 1. And you find the two numbers that multiply to the top and they add to the bottom. And what numbers work here? Probably 4 and 3. Which one's negative? Yeah, negative 3. So 4 times negative 3 is negative 12. 4 minus 3 is positive 1. So we have t plus 4 and t minus 3. Again, that's something that we want to get down to maybe 7 seconds or less. If I say negative 12 and 1, you should come up with 4 and negative 3 pretty quickly. Remember, this is the first section of a longer chapter, and it's not something we can afford to kind of be good at. Usually the first section is the easiest stuff, so let's get really good at it. The top, once again, you see a bunch of things being squared, right? Hopefully you think of 9 now as 3 squared. So 3 plus t, 3 minus t. It's kind of the same thing as p squared minus 49, it's just in reverse. Alright, so there's a good jump start to those few first problems. Again, these other ones, these are really fast. Just start canceling things on the top and bottom. You don't have to really think about a whole lot. Just be neat with it so you don't forget something. If there's a mistake on anything, there's so much canceling that you forget what's left over. Or it's so messy that you can't tell what's left over. Alright, one other thing I want to go over. Let's see here. Try to find the problem that has it. I think it's this one. Yes. First thing first, always do a GCF first. Always do a GCF first. When I say factor, there's a lot of little sub-steps. Look for a GCF. Look for a difference of squares. That's the p plus 7, p minus 7. Don't have to do a lot of thinking. And then you can go to the x and see if it's a trinomial, factor it that way. But this is the most common skip step, which leads to issues, a GCF. So like on here, you can see that there's an x in both of them on the top. You can see there's a y in both of them on the bottom. Do that first before you do anything else. You can take a GCF out, do it. And then bottom, there's a y in both of them. They don't have anything else in common, so I take out only the y. Okay. And then from there, go into the difference of squares. Now you can see, x squared minus 2 squared. X plus 2, x minus 2. Right, things will become easier real fast if you do that GCF first. x minus 2x plus 2. The only other little thing that you'll need to worry about is this right in here. Does anything else look like it's going to cancel? Is anything else exactly the same on the top and bottom? No. And that's usually the rule. It has to be exactly the same because canceling out means what after all? What does cancel out mean, by the way? It equals what? 1. Yeah, like 2 over 2. They cancel out. What does that mean? 2 over 2, 2 divided by 2 equals 1. X over x, they cancel out. What does that equal? 1. Okay. C plus 2 over C plus 2. What does that equal? 1. Why does it equal 1? Doesn't matter what number I plug in. C equals 5. Okay, 5 plus 2 is 7. 5 plus 2 is 7. 7 over 7 is 1. C equals negative 3. Negative 3 plus 2 over negative 3 plus 2 equals 1. So they cancel out. They equal 1. However, here, if I plug in a number, let's say 5, x equals 5. What do you get on the top? Negative 3. What do you get on the bottom? So what does this equal? Negative 1. What if I plugged in a different number, like negative 3? Yeah, I'd get 5 over negative 5, which equals negative 1. So we have this unique situation where they don't have to be exactly the same, but they cancel out anyway, but they equal a negative 1. So you just add like a negative in the front. So part of using a tool is knowing when to use it. They both have to be subtraction, and the order has to be reversed. That is a must. Nothing else. So if one's positive, one's minus, can't do it. So they both have to be subtraction, and the terms have to be reversed. They cancel out to negative 1. For example, right here I can see it. You see we have a t minus 3 on the bottom, a 3 minus t on top. So these will cancel, and you'll have a negative in the front. Okay. That's that one little thing that's kind of eludes us sometimes. The rest of it is just straight up factoring. We did a lot of beginning of the year doing a lot of this, so hopefully it'll just come back to you quickly. Do we need to go over anything here? Anything here we need to start? Real fast, how would you factor the top of 43? Just to review. What would go here? What goes on the top? Negative 24. So it's always multiply those two. What goes on the bottom? Hey, what two numbers work? Negative 6, positive 4. Now, what else do I have to do that's different because there's a number in front? All over 3x. All over 3x. So, does 3 over 4 reduce? No. Does 3 over 6 reduce? Yes? Yes, it does. So you have to reduce it. That's the difference when there's a number in front. You have to reduce it. So we get 3x plus 4 and x minus 2. And again, these will be in the warm-up. They take a little longer. You'll have more time to do them. Not a lot of time. I'd say 20 seconds or less you should be able to do that. That includes finding out the numbers are 6 and 4. That's basic times tables. Okay? And then, of course, remembering to reduce it. The number one mistake I've seen so far this year is people get to this point and they forget to reduce it. You've got to reduce it. 3 goes into 6. It reduces. And then the bottom, what's the first step for factoring here on the bottom? Yep, GCF. Before we do anything else, GCF. Okay, what next? Difference of squares. X squared minus 2 squared. So again, see how fast you should be able to recognize these. And now you can see things cancel out. Okay. So you're going to utilize the back of the book heavily You're going to check the back of the book after you do each problem. You're not going to move on to the next one unless you attempt it at least 3 or 4 times. I don't want you going through all of them halfway and getting them all wrong and coming on Monday and saying, well, I tried all of them, I did them all wrong. That's probably not a good thing. Okay, go through one by one. Today you got a half hour. You can get through a lot of these if you're working with the right people. Fortunately, I do not have a book for everybody so you can actually check your answers, but with each other, you can do a lot of collaborative stuff. So if you guys are getting the same answer independently, you probably got the same right answer. So in lieu of using a back of the book, which you'll use at home, you're going to use each other today in class to check each other's answers. And do not move on to the next one unless you know for a fact you got it right.
You put it back to the other one.
Okay. Yeah, I will in a second. Okay, go ahead and do that. Keep in mind there are people over here testing, so don't bother them. Don't talk to them. Let them have the fair shot as you had yesterday to do the test. And that's about it. If you need to watch any of this again, remember it's all posted on YouTube.